Hi guys, so today we're going to be looking at Chapter 7, Section 5, Factoring x to the power 2 plus bx plus c. So let's start off with review. The question is asking you to solve the equation 18m to the power 2 plus 12m. So I'll give you a few minutes to do that on your own first. Okay, so right here, we're trying to find the greatest common factor of 18m to the power 2 and 12m. And so right here, I'm going to take the greatest common factor by taking out the 18 first. And then seeing here, we would have 2 times 9. Over here is 2 times 6. We have 3 times 3, and we also have here 2 times 3. So our prime numbers would be 2, 3, and 3. And our prime numbers on the other side is 2, 2, and 3. So in total, we have a 2 in common. We also have a 3 in common. And so from that, 2 times 3, that equals to 6. Cool. And another way of checking to make sure that that is the greatest common factor is by placing the two numbers in a fraction. So right here, 18 and 12, if I were to divide both by 6, would I get a simplified fraction? We have here 3 over 2. 3 over 2 can't be simplified any more than that, so we could say that 6 is perfect. And then we also need the m to the power 2 and the m. So m to the power 2 equals to m times m. M, that just equals to m. So it seems like they only have one common m here. So I'm going to multiply the 6 and the m together, and I'm going to get 6m. So over here, factoring out 6m from both numbers, we get here, let's see, this divided by 6 would give us 3 over 1, and then we still have the m to the power 2 over m. And then over here, I could divide 6 to both numbers. I would get 2m over 1m. And so I could use the division rule, where that would turn into 3m, and then again over here, use the division rule, I would just get 2. And then the last part is to always add in the greatest common factor that you had originally. Cool. So let me clear this. And let's look at the new content for today, which is using power of x method. Now, let's say that the form of your polynomial, it looks like ax squared plus bx plus c. Now, in these cases that we're given this type of format, we want to use this x method to factor out our polynomial. And so whatever is our a and whatever our c is going to multiply together on the top of the x. And whatever our b is in the middle is going to go and be drawn on the bottom here. Now, I will explain the multiplying and adding later on, but for now, let's just try an example out. So right here, the example is, let me move it like this. The example here is asking you to factor out x to the power 2 plus 10x plus 16. Now, this one definitely has the ax squared plus bx plus c format. So I'm going to start off by finding out what my a is, what my b is, and what my c is. So we have here x to the power 2 plus 10x plus 16. And then underneath, I'm going to put down the ax squared plus bx plus c. Now remember that whenever there isn't a number next to a variable, we can always say that there's an imaginary one here. So we know that a is equal to 0, or sorry, not 0, 1. our b is equal to 10, and our c is equal to 16. Now once we have that down, I'm going to create my x here. So again, what goes on the top is the a multiplying with c. So we have 1 multiplying with 16. That would equal to positive 16, okay? On the bottom, we have b, and b is equal to 10. So 10 goes on the bottom of the x. So now that we know what is on the top and bottom of our x here, what we want to do is we want to find two numbers that will go on the left and right side. Now these two numbers need to be able to multiply to get 16, but also add to get 10. Now, how we're going to do that? We want to first start off by finding all the multiples of 16. So we have here 2 times 8, that equals to 16. We also have 8 times 2, that equals to 16 as well. We have 1 times 16, that equals to 16, and we also have 16 times 1, that equals to 16 as well. So in these cases, if I were to take the numbers that we're multiplying together to get 16, and then instead of multiplying them, I'm going to add them. And I'm going to see which ones would equal to 10. So 16 plus 1, that equals to 17, so that's not going to work. We also know that 1 plus 16 is not going to work either. If we look at 8 times 2, we can change that to 8 plus 2, that equals to 10, so that works out. So our two numbers here could be 8 and 2. Now it doesn't matter which side you put it, as long as you have them written down. Okay. Now the last step is creating the expression. We're going to take our original polynomial, which is the x to the power 2 plus 10x plus 16, and then underneath I'm going to write down the 16 on top, 10 on the bottom, 8 and 2. Now from this, I'm going to take the first term, x to the power 2, write it here. That will be my first term of the polynomial. The next one is going to be taken from the 8. Now, it's really important that you don't just put 8, but you're also multiplying it with x. The other number is going to be 2. Again, you're going to make sure to multiply it with x again. And then the last number is just going to be the 16. So, based off of this, I want to create two polynomials. One of them is going to be x to the power 2 plus 8x. And the other one is going to be 2x plus 16. Now, just like how we did in the review, I want to find the greatest common factor for both numbers. So right here, I'm just going to put a box right here. Now we have to find the greatest common factor of x to the power 2 and 8x. For both of them, seems like the only one that they have in common would be the x to the power 2 and the x, because 1 and 8, there's nothing that you could divide there. So we get x times x, over here is just x, so it seems like the only thing they have in common from both two terms is just x. So I'm going to divide x to both numbers, and I'm left with x times x plus 8. Let's look at the other one. The other one, the GCF of 2x and 16, we're just looking at the 2 and the 16. Seems like this one is prime, so the only prime number that they're going to have in common here. Because as you can see, this is going to be 2 times 2 times 2. So this one has 4 prime numbers. This one has 1. So the only one they have in common is just 1 prime 2. So here I'm going to divide both numbers by 2. And so I get here 2 times x plus 8. Now, the important part is right here. You have to make sure that your answer has 2 of the same polynomials. Because what we're going to do now is we're going to combine those polynomials together into one polynomial here. And whatever is left over is going to create our second polynomial. So we have a positive x that's left over. So I'm going to put that into my new polynomial. We have a positive 2 that's left over. So I'm going to put that into my polynomial. And so from there, we get our answer, which is x plus 8 times x plus 2. Okay. So let's try out another problem. So right here, I'm going to give you time to try this problem out on your own first. It says here, you're going to find the factors of x to the power 2 plus 4x minus 21. So for this one, let's go step by step first. So what I want you to do first is to create the x format. What is your A, what is your B, and what is your C? All right. So right here we have x to the power 2 plus 4x minus 21. Now, based off of these, let's see. We already said that there's always that imaginary 1 right here, right? So we know that our A is equal to 1, our B is equal to 4, and our C is equal to negative 21. And if you don't know, or if you have an issue with finding out what your A, B, and C are, you can always just write down the formula underneath. And that will tell you and guide you on finding out what your A is. Our A here is 1. Our B here is 4. And our C is negative 21. Oops. Make sure that we have negative 21. Alright, so now we can create our x. Again, what goes on top is A times C. So we have 1 times negative 21. That equals to negative 21. On the bottom, we always have B. And our B here is positive 4. So right here on our top is negative 21. And our bottom is 4. Now we need to find numbers that multiply to get negative 21 and add to get 4. So I'll give you time to try and find a number that multiplies together to get 21. Then afterwards, you have to find also a number that adds to get 4. Okay, so let's look at it. For negative 21, we have 3 times negative 7. That equals to negative 21. We also have negative 3 times 7. That equals to negative 21. We have 1 times negative 21. That equals to negative 21. We also have negative 1 times 21. That equals to 21 as well, or negative 21. Now we want to find a number that would give me 4. So right here, if I have 3 plus negative 7, that equals to negative 4. We're close, but we make sure that we have a positive 4. So let's look at negative 3 plus 7. That would give us positive 4. So we know that our numbers here have to be negative 3 and positive 7. Okay. So the next step here is creating our expression. So I'm going to use our original, which is the x to the power 2 plus 4x minus 21, and underneath I'm writing down the negative 21, negative 3, and 7, and positive 4. Now I need to bring down the first term from the example, which is x to the power of 2. Next one is whatever is on the left side of my x, so it was negative 3, and I need to make sure that I also multiply this negative 3 with an x. Over here I have positive 7, bringing that down and multiplying it with x, and then I'm also going to bring down the negative 21. Now the last part is to factor out the greatest common factors from x to the power 2 minus 3x and 7x to minus 21. So I'll give you a few minutes to find the greatest common factors to both polynomials. Alright, so right here it seems that the only number that could divide into both x to the power 2 and 3x is x. If I do that and I factor out x, I get x minus 3. Over here, I have 7x and negative 21. So it seems like the only thing I can divide into both is 7. So over here, I'm going to use positive 7. I'm left with x minus 3. And it seems to have worked because look, we have x minus 3 and x minus 3. So when we have that in common, that means that we have x minus 3 and we have our leftovers here. Our leftovers are the positive x and our positive 7. And so that gives us our polynomial, or our factored polynomial. So hopefully this helps. Good luck.